Now we'll try to solve another differential equation. We'll make it a little more complicated. Y prime equals x, y. So it looks a lot like the last one, which was an exponential solution. But this time the derivative is proportional not just to the function itself, but to x times the function. So let's see what happens. We're going to do the same trick as before. We're going to write out y prime. We'll write out y multiplied by x, and we'll set those coefficients equal. Let's see what happens. So y prime is going to be a1 plus 2a2x plus 3a3x squared plus 4a4x cubed plus 5a to the fifth, a sub 5 x to the fourth plus 6 a sub 6 x to the fifth plus dot dot dot. And we're writing this out because we're going to want to see the pattern, and it may not be obvious at first what that pattern is. So we're going to write it out. And that's y prime. And we got that by taking y and taking the derivative using the power formula. Let's write out y times x. Well, it's x times y, and y is just a0 plus a1 x plus a2 x squared, etc. And I'm going to multiply through by x. Each of these powers of the y is going to go up by 1. So the a0 is going to have an x, the a1 is going to have an x squared, the a2 is going to have an x cubed, the a3 is going to have an x fourth. Let's just write that out. So it's a2x cubed plus a3 x to the fourth plus a4 x to the fifth plus a5 x to the sixth plus a6 x to the seventh. And the reason I made this long is because it's not going to be obvious what the pattern is unless we examine a number of terms. Now we can see and set these two expressions equal. We're going to set this expression equal to this expression, and we'll look at all the powers. Now if you look at the y prime, it has a constant term, but the xy doesn't have any constant term. There's a 0 here times x to the 0. So we notice right away that a1 equals 0. That's interesting. Now 2a2 is going to equal a0 because equating the x powers. So 2a2 is equal to a0, and a2 is a0 over 2. Now let's look at a3. 3a3, this is the x squared term, is equal to a1. But a1 is 0, so a3 must be 0. So notice a1 is 0 and a3 is 0. Let's look at the x cubed term. We would have 4a4 equals a2, which implies a4 is a2 over 4, which is a0 over 4 times 2. We'll leave it as 4 times 2. Now, I don't know if you can see, but the a to the fifth term is going to be 0, because you'll notice that if you look at the structure of this first equation, y prime brings the power down by 1, x times y ups the power by 1 because you're multiplying by x, so the powers are separated by 2. So you have a1, it's nothing to correspond to, but a0 and a2 are related, a1 and a3 are related, a2 and a4 are related, and therefore a5 and a3 are going to be related, but a3 is already 0, so a5 is going to be 0. But let's just write that down. We're going to have 5a5 equals the x fourth term, a3, and they are separated by 2, but a3 is 0, so a5 is 0. And you should be able to see that a 7 is going to be 0, a 9 is going to be 0, all the odds are going to be 0. Because they're all separated by 2, but the one that they're related to is 0, and therefore they're all going to be 0. Let's look at the next even one. We would have 6a6 equals a4. So we've got looking at the x to the 5th power, 6a6 equals a4, a6 equals a4 divided by 6, but a4 is a0 divided by 4 times 2. And we'll leave it that way. I don't know if you can see the pattern. What do you think A8 is? A8 is going to be A0 times 8 times 6 times 4 times 2. Let's take a look at those. We're going to rewrite that. It sort of looks like a factorial, and it is a factorial if you factor out a 2 from each of these. So let's take a look. So we can write a2, going back to the beginning, we can write a2 is a0 over 1 factorial times 2. We can write a4 as a2 over 2 times 2. We can write a6 as a0 over 2 times 2 times 2 times 3 times 2 times 1. There's the 3 factorial. And we can write a8 as a0 divided, we can factor out a 2 out of the 8, a 2 out of the 6, a 2 out of the 4, and a 2 out of the 2. We're going to have 2 to the 4th times 4 factorial. Okay, what's the general pattern? The general pattern is a sub n, where n is even, make it 2n. That way we know it's even, is a sub 0 over 2 to the n factorial. And we can write out the solution. Y equals a0. Don't forget the a0. It's still there. Plus a2 will have x squared over 2 times 1 factorial. Plus, there's an a0 there, plus a0 x to the 4th over 2 squared times 2 factorial plus a0 a to the 6 over 2 cubed times 3 factorial plus a0 x to the 8th over 2 to the 4th times 4 factorial plus, and if you can look at this carefully, let's factor out the a0. I'm going to have 1 plus x over 2 x squared over 2 plus x squared over 2 squared over times 2 factorial plus x squared over 2 cubed over 3 factorial plus x squared over 2 to the 4th divided by 4 factorial. Where I've taken those 2's and I've absorbed them into this x squared over 2. And if you look at that carefully, that looks like a0, 1 plus z plus 1 over 2 factorial z squared plus 1 over 3 factorial z cubed plus 1 over 4 factorial z to the 4th. That is in fact a0 e to the z, which of course is a0 e to the x squared over 2. And that's the answer. Now you don't have to, it's a little bit of work to play around with these things. You could have just gone back and just said, well, the answer is these coefficients, but it turns out that this is what it comes out to be in terms of a function. Okay, we're going to stop here. We can do more of these. The next time we do it, I'm going to show you how to manipulate the sigma, use the sigma formula.